C4H8. First of all, it's a hydrocarbon, a compound made of carbon and hydrogen atoms only. It has a general formula of CnH2n, which tells us it's an alkene. In this case, but-1-ene. But what about its structural isomers? These are compounds with the same molecular formula but a different structural formula. We have chain isomers which have a different arrangement of the carbon skeleton. In this case, 2-methylpropene. We have positional isomers where the functional group is attached to a different carbon atom, in this case but-2-ene. And finally, functional group isomers which have a different functional group, in this case cyclobutane. Next up, we have stereoisomers. These are compounds with the same structural formula but a different arrangement of atoms in space. In order to have stereoisomerism, we need a C double bond C and two different atoms or groups attached to this double bond. Our first type of stereoisomers are E isomers. It's when the same groups are positioned on opposite sides of the double bond. In this case, E-but-2-ene. Next up, Z isomers, which have the same groups either above or below the double bond. Here we can see it becomes Z-but-2-ene. If the carbon atoms have at least one group in common, then we can call the isomers cis-trans isomers. Cis isomers have the same group on the same side of the double bond, while trans isomers have the same groups on opposite sides of the bond. Remember when we said C4H8 is an alkene? Well, let's have a look at some of the reactions of alkenes. I won't go into too much detail in this video, but here are some of the most common reactions. Number 1, combustion. We have both complete and incomplete. The carbon double bond is an area of high electron density, making it susceptible to electrophilic attack. Next up, we have hydrogenation, which involves the addition of hydrogen. Halogenation, the addition of a halogen. Hydration, the addition of steam. And last but not least, the addition of hydrogen halides. Thank you for watching.